We now continue with our technological and cultural look at the history of robots.
If the industrial robot has a family tree, its roots are firmly planted with this man. George Devol is known as the grandfather of robotics. It was his patent, filed in 1954, that was the blueprint for the machine that would revolutionize industry.
This is the kind of a job that a man normally doesn't like to do. It's really terribly hot, those forging operations.
Devol, a prolific inventor, also responsible for the barcode and the electric door, teamed with engineer Joe Engelberger, now known as the father of robotics. Joe says it all began at a cocktail party. Both men believed in the idea, but it proved difficult to convince companies to fund their project.
When we built the first industrial robot, to get the financing, I visited 46 different companies before I could find someone who'd believe it was even possible to do such a thing.
It took years of development and fundraising, but George Devol's blueprint lurched to robotic life in 1961. The new company was called Unimation. The robot was named Unimate.
Automation's newest contribution to man. This jack-of-all-trades robot is called Unimate, and it handles dull, difficult, or dangerous jobs with equal aplomb.
That same year, General Motors bought the first Unimate and put it in a New Jersey plant to take red-hot parts from a die-casting machine. Automation was not new to the automobile industry, but this was something different. The Unimate created the definition of an industrial robot.
An industrial robot is something that has at least 3 degrees of freedom, which means 3 axes that can move independently. It has to be reprogrammable, and it has to be able to perform different tasks. And that's the universally agreed definition today.
The original Unimate had an awful lot of the major qualities that all industrial robots have today. It had to have a memory. It had to remember up to 100 different steps. There's 100 different things in a row it could do.
He has muscle, can pick up 75 pounds, and can stand extreme heat, cold, noxious odors, toxic gases, and radiation. He never complains, asks for a promotion, or demands a pay raise. He doesn't break, bend, or burn, and should make some other Unimate a perfect husband. Or maybe wife?
It was a primitive machine weighing 2,000 pounds, powered by hydraulics, with memory stored on a clunky magnetic drum. Its nervous system was operated by feedback or servo mechanisms, which measure where the robot is in space. When it reaches its pre-programmed point, it then performs its next maneuver. Another innovation was the end effector, the robot's hand. This is the part of the machine that interfaces with its surroundings. Each is designed to do a specific job, and it allowed robots to weld, drill, spray, and grip.
The end effector is another word for tooling. Now, the tooling can get pretty sophisticated because some of the tooling has sensors built into the clamp, let's say, that will allow it to exert just so much pressure on something.
However, aside from General Motors, buyers for the new robots were scarce.
If you don't understand something, and to try to get a normal businessman to understand a robot, you know, he thought you're talking about science fiction or something like that.
Management was skeptical, workers fearful. Corporate executives believed the robots wouldn't work. Employees feared they would work too well and replace them. But robots mostly did the jobs people didn't want to do. And in fact, robots created jobs. Humans had to design, build, operate, and repair them.
So they're able to use the kind of brain power that they have. Like one of the people that went to one of our classes learning how to program robots came out of it and said, gee, now I can finally use my brains for this company I've been working for 20 years instead of just my muscles.
By the mid-60s, even labor unions endorsed robots. recognizing the inevitable increase in productivity. But the original Unimate with an $18,000 price tag remained a tough sell.
What we did to get people started, we would rent the robot. You'd hire it, like a person. And we would say, at that time I said it's so many $6 an hour, I think, for the first shift, and $3 an hour for the second shift. So your labor gets cheaper.
The robot had one thing advantage immediately, and that is the robot can work 3 shifts or work 24 hours a day.
George and Joe set out to change public perception of the new machines. So they took their robotic show on the road.
Would you welcome Joe Engelberger? Joe?
And ultimately, the show that was so important to us was the Johnny Carson show. And that's where the idea was, suppose we try to give the impression that the robot could do the whole show. So you had the 3 scenes. One, it could play better golf than Carson could.
Is that wild? Now, what he's doing now is to program what he's going to have the machine do. He's putting this information into the machine.
And that gave me a chance to show how the arm moved with a baton.
Take it on the downbeat.
But there was another market that saw the potential of robotics, the Japanese. Theirs was a nation in need of a labor force, and they immediately embraced the potential of robots.
The Japanese outclassed us in quality and cost and manufacturing and features, and that's where the difference was made. If I talked to an American executive, they wanted to know how fast they're getting their money back. The Japanese would look long range.
Kawasaki and Unimation formed a joint venture. The Japanese quickly took the lead in the robotics industry. While in the early 1970s, several Stanford graduates recognized the potential of these breakthroughs for private industry and formed a company to manufacture and market these intelligent robot arms.
That company had 3 people, Vic Scheinman, myself, and Bruce Shimano. The company was called Vicarm, which stood for Vic's arm, and we began to build small electric computer-controlled robots for research purposes.
The Vicarm could move with unprecedented precision and reliability. It was capable of repeating a motion with stunning accuracy. The partners wanted to take their invention to the industrial market, essentially giving the Unimate a brain. So like Joe Engelberger before him, Vic Scheinman took his robotic show on the road. Ironically, it was Engelberger who got him in the door, literally at a trade show in Chicago in 1975.
All of a sudden there was this commotion out on the steps, and we asked security to go out there and see what was going on. Well, Vic Scheinman was out there with a briefcase. He'd open up his briefcase and this little robot arm would move around. So we threw him out of the trade show 2 or 3 times.
And he was standing out in front of the show with a robot under his arm, and it was like a Frenchman selling filthy pictures, you know. And I said, come on in, Vic, and we'll put a table up at the corner of our booth and you can start showing people. And all the attention came to Vic's little arm.
Unimation was so impressed that they bought the Vicarm company. General Motors then commissioned them to create a new robot for automobile assembly lines. Together they developed a robot that set an industry standard, the Puma, programmable universal machine for assembly.
The Puma was an industrial version of the Vicarm technology. It had incorporated into its base an LSI-11 computer, a small microcomputer. It could move to a repeatability of 0.004 of an inch, which is about the thickness of a sheet of paper. That early computer had only 8 kilobytes of memory in it. And I remember my partner, Bruce Shimano, commenting to me that he didn't think he'd ever be able to develop enough software to fill 8 kilobytes of memory.
Unlike the massive hydraulically controlled Unimate, the Puma was a small electric robot.
The movement to an electric motor to help drive the robots really was a key point, and that was a benchmark time, and it created a lot of new application interest areas and expanded the industry quite dramatically, going from hydraulics to electric.
Originally, the Puma was sized to be about the same size as a person, and the idea was that it would be very difficult to get the workforce and the plants to accept this kind of technology, and if it was sized about the size of a human, you could imagine using some places where robots would perform the work or other places where people could perform the work, and if there were problems, you could backfill that technology with people.
Puma sales quickly grew to about $35 million a year, and a thriving industry in intelligent industrial robots was born. Soon, the vision systems were improved so robots could recognize and manipulate parts randomly placed on a moving conveyor belt. The robots were taught this remarkable task by first showing the parts to the machine's video camera eye. The computer would memorize that shape and look for a match as parts came down the conveyor belt. By now, robots had achieved intelligence roughly equivalent to that of a cricket.
One application in the mid-'80s was in the food industry, where robots were picking up candy that was coming down a moving conveyor belt, or cookies that were coming down a moving conveyor belt, using machine vision to find the candy or the cookie, then picking it up and putting it into an appropriate package.
During this time, General Motors bought about half the industrial robots manufactured in the U.S. and decided to form its own robotic division. Westinghouse also got into the game by buying Unimate. Carlyle and Shimano, not keen on becoming conventional corporate types, formed their own company called Adept. Today, Adept is one of the few successful American industrial robot companies. GM and Westinghouse have both dropped out, and the industry is dominated by companies from Japan, where the robot market is 5 times larger than in America. Japanese companies such as Fanuc Robotics have branches throughout the world. And although these companies didn't invent industrial robots, they have added new levels of efficiency to the technology.
They saw something good. They don't worry about whether it was invented there or not. They figure out how to use it most effectively for their objectives. Their most recent motor factory has 200 robots and 40 operators in the plant, and is capable of running overnight, unmanned, actually for a full 3 to 4 day weekend.
At Fanuc's headquarters, they even have robots building other robots. The Japanese have honed the once awkward robot arm into a dexterous tool eerily similar to a human limb. They proudly display the capabilities of their robots in impressive demonstrations. Robots balancing spinning tops on the edge of a sword. Or coordinating 2 arms in a demonstration of flower arranging. Or agile robot fingers manipulating a tiny bolt. And even a robot arm that uses its vision system to draw remarkably accurate portraits. The beret is optional. The next challenge was to move robots from the factory floor to the outside world.